So this talk is Lorentz transformations don't reduce to Galilean transformations for low speeds. So I've dealt with this in other videos, and now I'm just going to highlight this issue that the Lorentz transformations don't reduce to Galilean transformations for low speeds. Decided it's worth stating as a standalone from what other videos were saying with which were using it. There seems to be a lot of maths mistakes by people working on Einstein's relativity. And this is the relevant paper. It's called Two Myths About Special Relativity. So the most common form of the transformation by the real constant v, where v is representing a velocity confined to the x direction, is given by these equations, and that constitutes the Lorentz transformations. And it's where t, x, y and z and the other set t prime, x prime, y prime and z prime are the coordinates of an event in two frames, with the origins coinciding at t equals t prime equals 0, where the primed frame is seen from the unprimed frame as moving with speed v along the x-axis, where c is the speed of light. And the next equation is for the gamma, which is the relativistic factor. Galilean transformations are these equations. The first thing to note is y prime equals y and z prime equals z is the same in the both transformations. In Galilean transformations, that's the same as what you have in the Lorentz transformations. So first thing we do now is consider from the Lorentz transformations this equation x prime equals gamma, which is all time x minus vt, versus from the Galilean transformations that x prime is equal to x minus vt. And so we're going to look at how similar are these equations. When v is small, for the equation x prime equals to gamma all times x minus vt, the term which is gamma tends to 1 as v tends to 0. So the above equation of x prime equal to gamma all times x minus vt, that tends to the Galilean transformation equation x prime equal to x minus vt, and that is okay, which is showing that for low speeds that particular part of the Lorentz transformations reduces to the same thing as what the Galilean transformations has. However, the problem starts for time in the Lorentz transformation, and that is t prime equal to gamma, and that's all times t minus vx divided by c squared. For small v, the gamma tends to 1, the same as before, and that equation from the Lorentz transformation then reduces to t prime equal to t minus vx divided by c squared. But this equation from the Lorentz transformation, which is t prime is equal to t minus vx divided by c squared, is not the same as what the Galilean transformation has, which has t prime is equal to t. And the mistake that seems to be made by many relativists is to assume that Vx divided by c squared tends to 0 as V tends to 0. But that is not the case, because as V tends to 0 can make x arbitrarily large. If made V equals 0, then it would equal 0 provided x were a finite number, i.e. not infinity, and that's because 0 times infinity is not a properly defined number. So only for V is equal to 0 would Lorentz transformations and Galilean transformations be equal, and that's a trivial case. Thus, Lorentz transformations do not tend to the Galilean transformations at low speed for the general case of when V tends to 0. So restating it, the equation from the Lorentz transformations of t prime is equal to gamma, and that's all times t minus Vx divided by c squared, just does not tend to the Galilean transformation equation of t prime is equal to t for low speeds. Instead, it tends to the equation t prime equals to t minus Vx divided by c squared. So how can this mess with falsely believing Lorentz transformation reduces to Galilean transformations at low speed? Well, first thing to note is the moving goalpost approach to Einstein's relativity. The way relativity is dealt with is that it moves goalposts. It has extra things added to, or initial claims amended in some way, and I've dealt with this sort of issue of the moving goalposts by relativity people in other videos. Looking at Einstein's special relativity paper of 1905, it was called On the Electrodynamics of Moving Bodies. Einstein deals with Lorentz transformations, but there is no mention of Galilean transformations. And in this book, Special Relativity, Emergence, 1905 and Early Interpretation by Arthur I. Miller, it points out that Galilean transformations first appeared in 1911. However, another book called Subtle as the Lord, The Science and the Life of Albert Einstein says Galileans were named in 1908. So the Galilean transformations were not named until after 1905. Einstein in 1905 did not talk about Galilean transformations because they weren't named then. After 1905, Galilean transformations were named, and some unknown person decided that Einstein, talking about Lorentz transformations, was talking about a different theory to one using Galilean transformations. But there was no such claim by Einstein in 1905. That what he was talking about was a different theory to Galilean transformations. Thus, this same unknown person or some other unknown person made the false claim that Lorentz transformations reduced to Galilean transformations at low speed, and that was not in Einstein's 1905 paper on special relativity. Thus we see the method being used. Einstein in 1905 gives special relativity in his paper, then person or persons unknown start adding extra bits or making changes to what Einstein said, i.e. moving the goalposts. So the claim that Lorentz transformations reduce to Galilean transformations at low speeds, and that as a good approximation, is a false claim. Based on this false claim, the mainstream then forcibly restricts Newtonian physics by light speed c, i.e. in that situation it's not allowing Newtonian physics to have speeds greater than c. And so just carry on moving goalposts, building one mistake on top of another mistake. So that's the end of this little talk. I hope it highlighted the method of messing things up that the people who believe in Einstein's relativity engage in. Thank you. The end.